to this edition of GeoTalks Express, where we're going to be looking at tips and tricks in Global Mapper Pro. Thanks for being here. We're going to take a look at some unique and maybe lesser known or less popular features today associated with the Pro module or with the Pro version of Global Mapper. My name is Jeff Hatzel. I am a product manager here at Blue Marble. And today I'm joined by my friend and colleague, Mackenzie. How are you doing today, Mackenzie?
I am doing well, Jeff. I hope you're doing well too, and I'm excited to get into some of these Global Mapper Pro tips and tricks.
Yeah. Thanks for being here. These are always, little fun things we get to show off in the application. So before we get going today, just the usual. For those of you who are new, I should say, to any of our GeoTalks Express sessions. In general, you're in listen only mode. So that means you can hear us, but we cannot hear you. Everybody, however, should have a questions panel as part of the GoToWebinar dashboard. So please, do your best to send us questions. Mackenzie and I will try to get to them as best we can live. But then if not, you'll get a follow-up. And I believe there's usually a posting on our website as well, answering all the questions that come in. If you aren't able to stick around for the whole time today, also keep in mind that this session is being recorded. And so, give us a few days or a week or so for our marketing team to clean it up. And then that will get posted to our YouTube channel as well. Mackenzie, do you want to tell us a little bit about some of the upcoming Blue Marble events that we have on our radar here?
Absolutely. So continuing with our GeoTalks Express, this monthly webinar series that we do, our webinar next month for May is going to focus on our academic programs. So Blue Marble does support some academic licensing for teaching and learning with Global Mapper, as well as some of our other products. And we, along with those academic licenses, we provide, a set of academic labs to help people learn more about GIS and be educated on that. So we'll have a webinar going over some of the details of those academic programs and some more information on May 10th. If you are interested, you can go to our website to register for that now. And then for other upcoming events, we have training, and we're always doing some training for our applications. So if the tips and tricks that we show in this webinar entice you to learn more about Global Mapper Pro, or specifically LiDAR processing, we have public training classes scheduled for June, August, October, and November. So you can go on our website and sign up for those classes, whatever time works for you. I believe there's one in-person class coming up this fall, and then we do a lot of online classes as well. So you have a live instructor talking you through some workflows and you work side by side with them. Additionally, under training, we have geodesy training. So advanced geodetics, learning a little bit more about geodesy and learning about our geographic calculator geodetic software application. If you're interested in that content, we have a training coming up in May for that, coming up very soon. So if you are interested, again, you can find out more information on our website and sign up for those trainings there.
Great, thanks, Mackenzie. We have for the summer even, we have quite a lot going on. So that's always great for us to share with everybody. So before we hop into things today, I thought we might just walk through some of the tips that we're going to highlight in the application today. As Mackenzie and I were talking about this and discussing what we wanted to cover, we thought about both components of larger tools, maybe smaller Pro workflows that we thought were useful. And then in the end, we realized we were kind of going to talk about things that we just like in the application and find handy. So this is a varied mix today. We'll talk about some pixels to points and photogrammetric things, a few point cloud related workflows. We'll even talk about some RTK support, some touching on mobile data management, and a whole bunch of little tips that we wanted to share with you. Anything I'm missing from that, Mackenzie?
No, I think we've got a good list of content to show you guys in the next about hour here.
Alrighty, so why don't I believe Mackenzie's going to start us off. So let me go ahead and give you the screen here, Mackenzie.
All right, let me make sure I share the correct screen that I'm looking for here. And as that comes through, we should see Global Mapper pop up with an open workspace where I have some imagery loaded for reference, and then we see some camera icons on screen. Those are picture points or UAV collected images. And the first tip that we're going to go over here is masking in the pixels to points tool in Global Mapper. So for those of you who aren't familiar, Global Mapper Pro does have a tool called Pixels to Points for photogrammetric point cloud creation. So taking a set of drone or UAV collected images that have sufficient overlap and detail in them and processing those into an ortho image and then some 3D outputs as well. The source data for this process, for this pixels to points process, are these little camera icons that represent individual collected images. We can see from this flight that our camera is looking in towards the center of this circle. So I'm sort of orbiting around a singular feature area that I want to more accurately map. And I can use the feature info tool in Global Mapper to pick on any of these picture point icons and view the image associated with each of those features. So I can take a look at the images here. And now these images are looking at an oblique angle, and that's one of the reasons that I want to show masking with this particular data set, because as we fade out into the horizon here, as we get into the sky, the structure from motion pixel matching process that the pixels to points tool goes through to create the 3D outputs from this image set is not going to do so well. This sky is, it's not going to process well. We're not going to get a 3D representation of the sky. So I want to be able to remove that from the images. And I can do that within the Pixels to Points tool in Global Mapper Pro here. So I'll start by selecting the Pixels to Points tool from one of our LiDAR toolbars here. And that brings up the Pixels to Points wizard. Now, if you haven't seen this interface, this is a new sort of step-through process, a wizard for Pixels to Points that was introduced in version 24.1 of Global Mapper. And in this first step, I can add my loaded picture points, the ones that are loaded into my workspace currently, and get this list populated. I'll select my output folder, change my project name if I would like, and I can move to the next step. The next step in the wizard is going to be selecting the primary output that I'd like to create from this data. So whether that's a 3D model or mesh, a 3D point cloud, or an ortho image, this will be the primary output, what I'm most looking for from this tool. Next, I have the option to create additional outputs from the Pixels to Points tool, if I would like. I'm not going to choose to select any of those right now, but I will click the Run button to bring me to my overall Pixels to Points dialog. For users that have, familiarity with Pixels to Points, have used this tool in previous versions of Global Mapper, this is the dialog that's likely looking more familiar to you. Now, of course, in this dialog, we can add ground control points to increase accuracy. But, for this tip, I'm here to talk about masking. And this is a tool that people may not be aware of within the Pixels to Points tool. And we have this Create New Mask button to begin creating a mask or essentially cropping out a part of one of our input images. Clicking on that button, I'm met with a dialog where I have two options for masking. Either to draw the mask on the image, just like I'm digitizing an area feature in Global Mapper. With that option, I use left clicks and a right click to finish the feature to create the mask or an area of the image that I'd like to crop out. You can see when I hover my cursor over that created mask, it changes, allowing me to select this mask. And if I'm not happy with it, I want to redo it, I can use the delete key on my keyboard to remove the mask from the image. The other option that I can access from this new mask button is to mask regions by filling areas of similar color within the image. So this is really applicable for this image set because I'm trying to mask out the sky, which is generally a pretty consistent color in this image set, and it's different from, you know, the rest of the content in this particular image here. So I'll set my color matching threshold to somewhere in the mid-30s for this image. I'll click OK, and then I get an eyedropper tool over my image preview. When I click on an area of the sky, that color matching comes into play and we get that mask feature over the sky area here. I can scroll to zoom in on my image preview and we can see that that's pretty cleanly masked out the sky area. I can then move on to the next image, choose to create a new mask. If I'm creating a mask just for all the sky in these images, I'll use the checkbox to use this same method or setting for all the masks within this image set. Click OK, create my next mask, move to the next image, and so on until I've sort of cropped out all of those areas that I don't want to be considered in processing for the Pixels to Points tool process. When that is all done, we are ready to click run, and Global Mapper is only going to look at the portions of the images that are not covered by these masks, so the relevant data, and it'll speed up processing. You'll get maybe some better results to do that. So while I'm using this method to mask out the sky or the horizon area in an oblique image, this can also be used to mask out, you know, your data collectors, the people standing in the field as you're collecting this data, or cars within a certain area if you want to exclude those from processing, because those objects in motion sometimes don't reconstruct well with the structure for motion process. So there's a lot of capability for this masking option in Pixels to Points, and it's a really great tool to know about if you're using this tool quite frequently.
That was great. Thanks, Mackenzie. I often forget about how great the masking tool can be when we're applying it to, you know, an image workflow that really needs to have features masked out of it.
Yeah, it's a great little pre-processing tool that you can use with Pixels to Points.
Yeah, absolutely. We had someone ask if this can be automated or if we can do this for all our images at once. The answer to that is not just yet, but certainly something we've actually been looking at and hoping to add to the tool in the future. So we're gonna sort of think about photogrammetric point clouds now that Mackenzie was just talking about creating with us, and talk about some features in the new, or the updated, I should say, LiDAR compare tool, and then also the existing fitting point clouds tool. So what we're looking at here right now, I've already run this process just so we didn't have to wait for it live. So we're seeing some of our outputs already. But what I have loaded are 2 point clouds of the same region. The point cloud we're seeing on top is an actual LiDAR scan of a region, and that is acting as our control point cloud. Then the point cloud that's hidden is a photogrammetric point cloud of the same area. Now, you might notice that this point cloud is colored and styled a little bit differently than we're used to seeing. For those of you who are familiar with Global Mapper, you'll know from right here that my point cloud is set to be colored by elevation, and this is clearly not quite the same range as my elevation data here. And what we can do in Global Mapper is customize the styling for a specific layer. And you do that right in the layer options for the LiDAR draw mode. And in this case, I'm coloring by what's called the generic value, which is an attribute we use to hold a variety of information. In this case, it's holding some output information from my analysis process. So my goal here was to understand the difference of my photogrammetric point cloud from my control LiDAR data. And to do that, I use the Compare Point Clouds tool. This tool allows us to look at a couple different point clouds. We can specify how far we want to search from given points to understand what variation may be between them. Right, I don't want to compare, a point in one location to a point 100 meters away. Right, they're certainly not going to be related. And then one of the exciting things that I like about this tool is the ability to save a distance report and also save the distance of the offset that we have in our point cloud. And so the result of running this for me was a couple different histograms. The middle one here being of interest to me, right? So this one is showing me the difference, how far given points are in my photogrammetric point cloud from the control point cloud. And so you'll see there, ranging from, right on top about 0 meters all the way up to about 0.2 meters or so here. So overall, reasonably close. And you will get a report with that information as well. And so you can see your mean, your standard deviation, and then this completeness value tells us how much of the source point cloud was compared, right? So I restricted that region a little bit in terms of my point spacings. And so about 40% of the point cloud fell into that region and was compared in that way. Really, a couple exciting new features here that I like is the ability to save both the plot and a text report of this output. So let me grab those from off screen. You now have the ability to save out the diagram itself as a PDF. So I saved that out as a PDF file, and that's, if you ever include that in a report or anything like that. And then also the, let's grab, where's my difference report here? Just a little text output showing me those summary values from the point cloud. So at this point, the reason I have my profile open is so that I can see kind of the differences between those point clouds. And at this point, what I would probably do once I understand that difference is to run the fit tool. And this will go ahead and adjust, in this case, my photogrammetric point cloud to my control point cloud. I would change those toggle settings here if we were running this live. I want to adjust the photogrammetric point cloud to my control. In this, I have the ability to specify a variety of settings pertaining to how far apart I'm allowing my points to be part of the shift. If I'm doing any thinning, and how much I want to thin my point clouds to help speed up processing as well. And I'm going to go ahead and I have a different output saved here so we can kind of toggle in between and see. So we'll notice here there's a bit of offset and difference. Once I have fit that point cloud, we'll see now how much more cleanly those two point clouds line up with each other after being fits to the control point cloud. So a whole bunch of really handy little ways to get an understanding of how our point clouds are offset and how we can go ahead and shift them if necessary. I did forget to mention in the initial compare tool, you also have the ability to create an output that is just all of the points which have shifted. So this is a subset of the data where we see points which have changed. So maybe you want to have a better understanding of where it looks like there's differences in your point cloud. You can go ahead and save just those changed points as well and get a better feel for how and where things may have changed. All righty, I'm going to pass it off back to you, Mackenzie. Did you happen to notice if we had any questions come in there?
There were a couple questions that come in. Someone's just asking for a little clarification on how that difference between the 2 point clouds is, created, how that's calculated.
That's a good question. A little bit in depth off the top of my head. But what we do is it's essentially a three-dimensional comparison where you look at points in the given region. So I think I specified 5 point spacings in this example. And so from my control point cloud, what points am I seeing in that region and how far away are they? There's a little bit more advanced stuff going on there that I can't rattle off the top of my head, but I can certainly get you some more details on that.
All right, and if you guys think of questions later after this webinar or while you're actively working in Global Mapper, don't ever hesitate to reach out to our technical support staff, geohelp@bluemarblegeo.com. I believe we're going to have that email at the end of this webinar, but we're always here to answer whatever questions you have, whether it's about how you can use the Global Mapper program better or about how a specific tool works. Don't ever hesitate to ask any of those questions. But for our third tip here in Global Mapper Pro today, I am going to continue the theme of working with some LiDAR data and create some contour lines directly from this LiDAR data. Now, the typical workflow for creating or generating contour lines from 3D data would be to take a point cloud, create a grid from it, typically a bare earth model or a digital terrain model, and from that raster model, then create contours. But in the contour creation tool in Global Mapper, you're able to skip a step there and create contour lines directly from this LiDAR data. So in this workspace here, I've got a tile of point cloud data, a little bit of imagery for context. We can see that there is some vegetation and maybe some other structures in this area. So I will take a look at this point cloud data viewed by classification here. I can also open up the 3D viewer and take a look at this data in 3D. Looking from the bottom of the data is a nice way to see the continuous aspect of the ground classification for a point cloud. But I can see I've got vegetation and some other classes still unclassified here, but I've got a pretty good ground classification. And since I'm looking for contour lines mapping the shape of the earth in this area, I can use just those ground classified points in order to create the contour lines I'm looking for. Now, to do this in Global Mapper, we have a generate or create contours tool up on the analysis toolbar. I'll click to open this dialog. We can name the layer. I'll create some 5-meter contours. And since I only have a LiDAR or a LiDAR point cloud loaded in this workspace for 3D data, Global Mapper knows that I'm working from LiDAR data to create these contours. And I've got a filter LiDAR button here that I can use. This opens the advanced filtering dialog for LiDAR data, and I'm just going to filter by classification, use only the ground classified points for the creation of these contour lines. Down at the bottom of this dialog, I'm going to discard any shorter contours, any shorter closed contours to maybe remove any small artifacts from this data set. And with that, I'll click OK. And pretty quickly here, Global Mapper under the hood is going to, interpolate between those ground points, sort of create that DTM model. But instead of saving that as an output, we're going to jump directly to our vector contour lines. And so here I can turn off the point cloud, and I've got these contour lines I can view in 2D and in 3D. These are 3D lines. They retain the elevation for the elevation of each individual contour line. And it's a great way to view this data, maybe lay this over some imagery so that I can add a little more context and detail to any map that I'm creating here. Going one step further with this tip and trick, I'm going to change the styling of these generated contours as well. So They're currently showing in brown, which doesn't show great against the imagery that I have here. And since these are vector features, they can of course be exported to any supported vector format. But by double clicking to open my vector options, I can also just change the style of these contours right in Global Mapper. And some of you may be aware we've got quite a few styles and customizable colors we can choose from here in this dialog. But I'm going to choose the elevation solid style. And what this is going to do is color these contours based on the active elevation shader that I have. So I get that nice Atlas shader visualization on my contour lines. So even when I'm looking in a 2D view, maybe when I don't have the labels displayed for these lines, I'm able to see sort of a relative elevation change throughout these lines, and adds a little bit more detail to this map once again.
Yeah, that styling is really just a great way to help make that data pop and add a little more information to it visually.
Absolutely. So I always recommend, if you're struggling to differentiate between data layers in any GIS program, but Global Mapper specifically, try changing up those styles and exploring the different options that we have, because it can just make your map and your data more readable and much more easy to interpret.
Yeah, absolutely. We had a question come in. We've answered a few questions privately, but this one is a good one. I think will pertain to everybody. Somebody asked about making contours of bathymetric data. Do you want to speak to that a little bit, Mackenzie?
Absolutely, that's definitely something Global Mapper can do. When you're working with 3D data in Global Mapper, whether that's a gridded version of 3D data, bathymetric or terrestrial, or point cloud, bathymetric point cloud data versus terrestrial data. Global Mapper doesn't discriminate. It doesn't care between the two. It just interprets that as 3D data. So anything that you see us doing here with this terrestrial data, the point cloud comparison that Jeff showed, creating contour lines like this, creating gridded versions of point clouds, that can all be done for bathymetric data as well as your terrestrial data. So it's wide open for however you want to use Global Mapper and the tools that the application provides. It's a very data-driven software, whatever you have to throw into the program.
Yep, absolutely. It's really a cool way for us to see data too. Bathymetric data isn't always as common, so it's a fun workflow for us to see and work with and hear about. Okay, I'm going to steal the screen back from Mackenzie for a few here, and we're going to take a look at a couple other point cloud related workflows. I wanted to talk about some less flashy but really handy things that I find I like to do when working on some point cloud editing and cleanup. It's not always necessary for us to really get into the weeds of editing our point clouds. Other times it is, and there's ways that we can speed up that workflow. And so here we're looking at a point cloud that was a terrestrial scan along this road. And, I've already automatically classified this. And so that's where all these different colors came from, different automatic classification methods of my buildings, my trees, my power lines, a few power poles. But what I wanted to talk about in this case for some manual editing, first thing we're going to do is go ahead and take a look at a profile view of this car. Now, in the scheme of things, this car was not remotely the focus of this scan, right? We were focused on the street and the power lines, but it's a good object here to show some things that I want to do. Right, this car very clearly stands out in my profile perspective. I see it in my top-down view, and it would stand out in 3D view as well. And maybe I need to quickly identify and remove these, work with these, whatever the case may be. So the first thing that I'm going to do is go ahead and I'm going to create a new classification manually that I'm going to call, in this case, let's call it cars. From the filter LiDAR tool, we have a whole long list of classes, and some of these are ones that already exist from the ASPRS, and others are just, placeholder definitions here. So I'm going to go ahead and grab one that isn't in use yet, and I can right click on it and choose to set the name. So maybe I'll call this cars and trucks. Let's see if, if I come across any trucks. And I can also go ahead and customize the color for that class. So anytime I see it on the map, it'll have a certain color, and we'll grab something that pops here a little bit. I'll just also note, I like to note the code number. So this is class code 30. Keeping in mind at this point, technically you are, now outside of a standard ASPRS classification number. That doesn't really matter for most things. So I'm going to apply that and hit OK. And now I need a quick way to manually add all of these points as cars. And I'm going to use a little hidden tool in Global Mapper that allows me to set up favorite shortcut keys. So I'm going to make a keyboard shortcut that allows me to assign things to the car class. So first thing I need to do is choose my action, and that was class 30 that I set to be cars and trucks. And I can choose a variety of available keyboard options here. I'll leave it as the comma, right? In this case, anything that's not held by Windows by default is available more or less. But I'll just go ahead and I'm going to add that shortcut. Now I can go ahead and select my car in 3D. Worth noting, whole bunch of different useful selection methods in the profile view. Really handy way if you need to customize how you're working with some of your point cloud data. I'm choosing to just select everything above a line I draw right now. So we'll say just about that. That is all my car. And then the keyboard shortcuts will assign those to the class. It will ask me if I want to. And then now we have our cars, and we can see they are added to that class. This type of selection, we don't talk about it as often, but it also works in 3D view. We'll see how my 3D view cooperates here. But I could also, select some points that I find are the car. Let's see how this works streaming here. I'll go ahead and select maybe just the edge of this car. Let's see how that goes. And then we'll see the selection is highlighted. So that's why those points are a little lighter. And I can go ahead and, it's thinking here, but it's taking its time because it's trying to stream this live. Let's see if we can do this and change the class to 30. There we go. And now those points should, there we go. It's catching up now, and we can see those points have changed as well. So a couple of different ways to quickly select and interact with those points and kind of manually edit them. While we are in this data set, I'd like to take a look at another tool that we have that we don't talk about as much, but I think is really useful, especially in workflows where you're dealing with any sort of data that is a corridor or anything right of way, whether we're talking pipelines, poles, trains, highways. You need to find how things relate to each other. We call it the Select LiDAR by Distance tool. So I'm going to go ahead and pop this open. And what this allows me to do is I'm going to say I need to find all trees that are within a certain distance of my power lines. In this case, let's just look within 10 feet. Keeping in mind, you always want to do this three-dimensionally, especially if you're working with point cloud data, right? We care about X, Y, and Z. So always make sure you're doing that three-dimensionally. I'm going to work with selecting all of the medium vegetation or the lower trees that I have classified in my point cloud. And I only care about ones that are within 10 feet of my power poles, and my power lines. So the result of this process will give me a selection of all of the points that fall within that region. And then I can choose to do a variety of things with them. Most likely I probably don't want to delete them. One thing I may want to do is maybe copy and paste them into their own layer so they're isolated. Maybe I want to make bounding boxes around them so I have an area feature which represents them, and I can then send that to somebody in the field with Global Mapper Mobile who can look and say, okay, does this tree need to be addressed at all? Or does where this power line and pole run through this tree, do we need to clean that up at all a little bit? So a really handy way to get an understanding of where we may need to go address things in the field for any type of encroachment analysis. And speaking of mobile data there a little bit, I'm going to pass it back over to Mackenzie, who's going to touch on that a little bit for some of her subsequent topics here.
All right, thank you, Jeff. I am going to talk a little bit about using a GPS unit or GNSS unit to collect some data in Global Mapper, and then talk a little bit about the mobile data management tool also available in Global Mapper Pro. So to start with, I'll talk with connecting an external GNSS unit to Global Mapper Pro and the desktop version here, and how we can use some RTK corrections to help boost the accuracy of any data that we're collecting here in Global Mapper. So to start with, in this workspace, I just have a tile, or the town of Hollowell, where Blue Marble Geographics is headquartered here, and a small tile of imagery. Right in here is where our office is, so that's where I am doing this webinar from right now. So once I get my GPS device hooked up, we should see my location pop in right about here. But in order to set up a GPS stream or GPS device in Global Mapper, we have a GPS menu and a GPS toolbar. So I'll start from the GPS menu and move to the setup option. And we have some options here to connect a GPS device. So you can use a cabled connection here, but I'm actually going to use a Bluetooth link to a device that I have sitting over in my office window right now to get a good look at the sky. I'll turn the Bluetooth on for my machine here in the Windows settings, and I have my MLID Reach RX little handheld GNSS device paired here. With that, I can set my format to auto detect to find my connected GPS device, or use the specific options that I have here. And before clicking OK to start streaming in a location from that device, I want to check my RTK configuration, my RTK corrections for real-time kinematic corrections here. And this is a great way to boost the accuracy if you have this option available. So here in Maine, I'm connected to a state maintained source that we've gotten some access to. I have the host or IP name, the port, my specific credentials for this, and I have chosen the location update interval. So how often we're going to be updating or improving our location from this source. I can also select the mount point, or where I'm getting these specific corrections from, based on whatever is relevant or nearby to the area which I am in. And since that's all set up appropriately for this RTK configuration, I'll click OK. And I want to make sure I have this checkbox enabled. So I'm actually going to use the RTK configuration when I start using my GNSS device here. With that, I will click OK and click yes to start tracking my GPS as soon as I click OK here. And with any luck, that should work, and we should see a little GPS icon pop in on top of my imagery. I can turn that off. That might come through a little bit better over the webinar. We can see that GPS location. Now, I'm streaming this directly from that external device into Global Mapper. So this might be a great setup if you have a laptop maybe mounted in a truck with a mounted external positioning device that you can, go out and collect field data and record a track log. By default, with this GPS option, a track log starts recording as soon as you connect that GPS device. You can then save that track log, once you've moved around and you want to create a line feature tracking where you've been. And choosing to save the track log brings up the modify feature info dialog, where you could then name a layer and create that line feature. From the GPS menu, you can also clear the track log to then start over and start recording that track from scratch again. Other options within the GPS menu or the GPS toolbar would be to mark a waypoint, and this just creates a point feature at the location being streamed in from the external device. So a GPS informed point feature. And then we have options to view GPS information and display the satellites that we're seeing here. And these are windows that I can move around. They're floating pane windows in Global Mapper, and they're dockable. I can actually dock them together in a bit of a tabbed view here. So I can see the satellites that my external device is talking to, where I'm getting that positioning from. And then on my GPS information tab here, I can see my accuracy, and that's definitely boosted by the use of the RTK correction. We can see some of that RTK information down at the bottom here, our current location and current elevation. So we've got a lot of information streaming in here, and you can create this GPS data directly in Global Mapper. I'll close that dialog and use this stop tracking button to stop tracking this GPS. And I don't have to go through this whole setup process again if I want to resume tracking with that device. I just simply click the button to start tracking, and since my device is connected and all set up in Global Mapper already, my GPS location pops back on here. By default, that setup RTK connection is enabled and starts streaming in information as well. So it's really easy to toggle that GPS location on and off. So that is one way to collect some data in using a GPS device, with the Global Mapper system of programs. The other way would be using the mobile app or Global Mapper Mobile. So Global Mapper Mobile is a mobile application available on iOS and Android that allows you to take data from Global Mapper right into the field for either reference or to collect data using the internal location services of the mobile device, or with the Pro Edition to Global Mapper Mobile using an external device, just like I was using with Global Mapper here. So to help Global Mapper desktop interface with the Global Mapper mobile application, we have a tool called Mobile Data Management here. And what I can do is enable the Mobile Data Management tool, and we've got 3 tabs. Now I have a mobile device data link where I can wirelessly transfer data through wireless internet connection between my desktop computer and a iOS or Android device. I next have my package file export tab where I can create a map to share to a mobile device running Global Mapper Mobile. And this is going to, by default, show the layers that I have enabled in my Global Mapper workspace. I also have the option to add a template layer here. A template, if you're not familiar, is the structure for a layer, and this can be configured in the configuration options in Global Mapper. I can add one of the few templates that I have here. Maybe I'm surveying the condition of lampposts. I'll name the layer, select the template, add that, and that's added as an empty layer, just guiding the user on how to collect data in Global Mapper Mobile. From here, of course, we can save this out to a GMMP file or a Global Mapper mobile package file, or upload it directly to a device through that mobile device data link. Now I'm going to go ahead and unload this data, pretend that I've gone through the process of, creating that global mapper package file, sending it out to the user in the field. They've gone out, they've collected some data, maybe right around the Blue Marble office here, and they've returned back with their data. They've sent it to me via email maybe, and I want to combine that collected data with the original global mapper mobile package that I generated from this program. Again, to do this, I'm going to open the mobile data management tool here. I've got the package file import tab where I can load in data from a global mapper mobile package. And I'll click the load button to do that. Here I can choose the file that I want to merge data from. This here is the edited file, the file that I sent out to the user in the field. They collected data, they saved a new version of this file and sent that version back to me. So this is my received version. My file to merge data to is my original version because I want to add my new features to my original created package file. I'll click OK, and this view here breaks down the different features and layers in the package files. We can see we have a column for the to value, a column for the from value, and we can see where whole layers may be different or missing from one file but not the other. And then under any specific layer, if there's a cluster of features that have changed, we can see point features. Now these point features only exist in the from file or that edited package file. So this is the data that the field collector went out and added in Global Mapper Mobile and is, now I'm merging back into some data in the office here. To better understand what these list items are representing, we can click the View button up at the top of this dialog to view my two packages side by side here. So here we have the to file, or my original data, and now we have the from file. And we can see that these two views are linked, so as I scroll or zoom in one, the other follows suit. So we're always looking at the same area in both of these views. And zooming into this particular area here, we can see the new features that were created. I've got an area feature covering the parking lot and a variety of points around the property here. So that represents all of these features with question marks here that I need to decide whether I want to keep the edited from file version or the original to file version. To make those decisions, I'll simply right click and choose to either keep the from item or keep the to item. A little arrow indicator will be at the beginning of the row to show which one I've chosen. I can make this decision for each individual point feature in one of these layers, but since all of these features were created and only exist in my from file, I'll just click on the layer or the feature group and apply that option to all of these features in each of these branches. Once I have all of those designations set, I can close the view option here. I've straightened out what data I want to keep from what files, and I will click the always load after merge option so my data automatically loads into Global Mapper, and finally click merge. This will create a new Global Mapper mobile package file that I'm naming right here, the merged version of my Blue Marble headquarters package file here. I'll click save. I've got the export option dialog for this format. Click OK. It'll export this merged data to that file location and then prompt me to load this data into Global Mapper. At that point, I can close the mobile data management tool, and we can see that I have all of the relevant layers that I wanted. I've got those original reference layers that I've decided to keep, and then the newly collected data here. Turning off the imagery so we can see that a little more clearly. We've got a parking lot feature, and then we've got a variety of points. And these are all vector features. They were just collected in the field with GPS methods using Global Mapper Mobile. We've got all that advanced GPS information that comes from using an external GNSS device and RTK corrections in Global Mapper Mobile, as well as any attributes designated when these features were created. So a couple different ways here, 2 tricks or 2 tips in Global Mapper Pro for collecting and managing data that is collected in the field or comes in collected from the field using Global Mapper Mobile Pro. So, Global Mapper is a data-driven program that often lives, in the office and is used for a lot of data processing and analysis. There are also tools for that data collection in the field, either with your whole machine, your laptop outside doing that, or just a smaller handheld mobile device in the field collecting data.
Mackenzie, we had a question come in, and I will maybe give you a second question on top of that. Someone asked what device you use to record the points, if you also happen to use the MLID for that. And then I was wondering if you could speak to the devices we support in Global Mapper and Global Mapper Mobile.
Absolutely. So I did use the MLID Reach RX for data collection in Global Mapper Mobile. I use that with a Samsung Android tablet that we have for testing and working with some of that data collection. As far as other devices that are supported in Global Mapper Mobile, Android supports a wider variety just because there are some restrictions with iOS Bluetooth connection to some devices, but Global Mapper Mobile does support Bluetooth connection to external GNSS devices, as well as connection over TCP IP communication. Of course, we support the MLID RX for that Bluetooth connection with Android. We support Javad devices on both iOS and Android. EOS devices, I know we've tested with. We try to get as many as we can to test with. And if users have specific devices that they're interested in, we're happy to try to get our hands on one, or help you go through the testing and troubleshooting process to make sure that you can get everything connected and working for your data collection. And then in Global Mapper, the desktop program, the first GPS connection that I showed, we have that Bluetooth connection, and I don't believe that there are any restrictions on that for connecting to a Windows machine. And there's also the option for a cabled connection to a external positioning device as well.
Great, thanks, Mackenzie. So we are just about ready to wrap up here. I have a couple other workflows that I wanted to talk about. So let me go ahead. I will take the screen back from Mackenzie. And we're going to look at a couple cool little workflows associated with the newer script builder in Global Mapper. So the script builder, for those of you who have been around Global Mapper for a while, know that Global Mapper has its own scripting language. Within the last couple of versions, we have also added support for Python. And now we have a tool called the Script Builder, which essentially records your actions as you take them in the form of Global Mapper script. And now we're working on the ability to save those as Python commands as well, so that if you have a process you want to automate, you can go ahead and do so and have the text copy of the script as a starting point to use for the future. So I'm going to launch the script builder. Sorry, came up on my other screen there. And to start, it's pretty bland. It's running to start by default. You can stop it, export your script. We'll take a look at it in the editor and then choose your language. So by default, it starts in Global Mapper script, but you could toggle over to Python just as easily. Let me go ahead and move this over here. So what I'm going to do is go ahead and open a file, and let's go ahead and load this point cloud. And I'll change my coloring here. And so you'll see the action of loading the data. In this case, I have both a point cloud and an area feature here. I don't really need the area feature, but we'll see the action of loading the data was recorded in my script builder. The point of this workflow is also to show another hidden little tool for the scenario where, in this case, I have a point cloud that has RGB attached to it. And we'll zoom in, we'll see the individual colors on the points. This is a pretty dense point cloud. It's actually reasonably high quality. And now I don't have any imagery for this area, but for my purposes, I need to have an image base map. Similar to how we talked about creating a three-dimensional terrain grid, we can also create a two-dimensional imagery grid essentially from this data set using the same tool. So when I go to create an elevation grid, I don't need to use my bounds layer here. I can choose, rather than doing it on elevation, creating my grid based on the RGB value. And instead of getting a output that is an elevation, it's going to be a color. It's fairly straightforward. That process also gets recorded in my script builder. And now I have an imagery layer here of that same data. I'm going to go ahead and export this quick so I have a copy of it that exists outside of Global Mapper. I'll just put it to JPEG 2000 right now. I'm not too concerned with my settings, and I'll just throw it on my desktop as a little test. And that will get recorded as well. So really handy way to get yourself, especially if you have high resolution point clouds, to get yourself a decent reference base map image out of the data. Now let's take a look at the script builder a little more. So I'll go ahead and stop recording right now. And so I initially recorded everything in Global Mapper script. I can easily toggle over to Python and have it show up in the Global Mapper Python libraries as well. Or at least you get a subset of it. You're not going to see the whole set of parameters here. But you can toggle between languages very easily. What I might want to do here then is I could export this out and save it right to a file, but I may want to begin working with it right away. So I can open the script editor in Global Mapper, and now I'll have that full set of commands and parameters associated with the Python. So I can continue to edit in here. This is a live text editor with syntax highlighting. So you'll see your commands, your parameters, your comments, and things like that, all ready to go right in Global Mapper, either in Python or in, maybe I'll go back to Global Mapper script and open it in a new tab here with Global Mapper scripting language as well. So a really useful way to work with scripting and automation and kind of move between languages as you need to work with them and learn them. So I know we're getting close to the end of our hour here. I just wanted to take a look at one more quick little tip. I don't need to save this.
Jeff, I do have one more tip to insert before you move on to our last one, if I can steal the screen from you again.
We can, yeah, go ahead. I didn't mean to forget you there.
All right, so keeping on the theme of working with 3D data, Jeff created used the elevation or the grid creation tool to create a different type of grid from a point cloud. I'm gonna go the other way with this tip, and I'm gonna create a point cloud from my digital elevation model. This is a digital surface model specifically. So here in the 3D view, we can see that we've got all these buildings captured, we've got vegetation, all these structures, cars even captured in this data set. And this is a workflow that I've seen from a lot of users recently, actually, where they have data like this. They have a surface model, but they're looking to create a bare earth model. They're looking to cut off all of these building and vegetation features and just get the ground surface modeled in a raster format here. So to do that, the best way I believe to do that is to take this gridded model and convert it back a step into a point cloud. Now you can see this has 4 tiles that are creating up this area that I have displayed in Global Mapper. And from the layer menu here, under terrain point clouds, we have the option to create a point cloud from an elevation layer. This is going to create 4 tiles of my point cloud, 1 for each of my DSM layers that I have in the workspace here. I'll generate that point cloud. We saw it viewed by classification pretty quickly right there. And I'll turn off that underlying DSM layer. We can now see in 2D and 3D these points. A point was generated at the grid cell center of every grid cell for these tiles here. And that tile structure is maintained in this created point cloud too. Now, these are 3D points and we can work with them to some extent like LiDAR data, but it is good to note that these were just created in Global Mapper. So they don't have all of the attributes or characteristics that you might expect from a true LiDAR collected point cloud. Like we're not going to have an intensity value. We don't have RGB colors. We just have elevations to show. We have no return numbers associated with these points. And since these were just created, there's no classification here either. But nonetheless, we have this 3D point cloud and that opens up what we can do with this data in Global Mapper. Remember, our goal is to just identify the ground and remove everything else. So for that, I'll view by classification and use the automatic LiDAR ground classification tool in Global Mapper Pro here to quickly classify the ground points in this data set. We can see in 2D and 3D that does a pretty good job. You know, we're removing or we're leaving unclassified vegetation, buildings, cars, smaller features, and we've got our ground clearly identified. Now, as a final step to finish creating our digital terrain or bare earth model, I'm gonna bring up that create elevation grid tool, work with my point layers here, and filter these layers down by classification, only using those ground classified points that I've identified. So this is the action of removing all of the structures and vegetation sitting on top of the ground. I can set up all the other grid creation options that I have here. I'll use a fine spacing of 1 feet to match my original DSM data sets and click OK to very quickly generate my bare earth model that I can then reveal by turning off those point cloud layers. Viewing this in 2D and 3D, you can see we've removed all of those structures and vegetation, all those unclassified points, and we're left with this bare earth model. And again, this was derived just from starting with those digital surface model layers. So just another way to creatively utilize the tools in Global Mapper to work a little bit backwards and then forwards to get to your desired output.
That was definitely probably the coolest workflow of the day. We should have ended on that one, I think. Always a great way to see a unique use of our data sets, or our tools, I should say. Okay, so before we keep everybody too much longer, we're going to take a look at one last subset of a tool in Global Mapper. For those of you who follow Global Mapper Pro, version or so ago, we released our first geostatistics tool called Kriging. Kriging, we can think of it as an advanced way to interpolate values based on sample points. So in this scenario, and I've run the processing while Mackenzie was talking, so we didn't have to wait for it. In this scenario, I have a variety of soil samples. In this case, we're looking at zinc concentration. And what I wanted to do was estimate the concentrations of zinc at locations that weren't sampled. The point I want to highlight here is that this process can be very technical with a lot of settings. All of this, again, can be saved out as PDF, just like we saw earlier. So I can create a variety of PDF outputs of my graphic products. And so in general, what these are telling us is I'm loading in my source data and I'm analyzing it for variance. So how do the values change over a given distance? And I can also visualize that based on cardinal direction. So is there any directionality to my data? If we're thinking, 0 to 360, do I have stronger variation in certain directions? And that might be important to me. For those of us who are not experts in kriging and geostatistics, the application will recommend the best model for the data, although there are a variety of models which you can choose from should you have the desire or knowledge to learn about them. What this product also gives us is a variety of different outputs. Most importantly, my new estimated surface. So now I have estimates of my zinc concentrations at all of these regions, not just where my points exist. And we can see how those values relate to the spread of my points. Equally important, I have the ability to get an initial estimate of uncertainty. As we would probably expect, the uncertainty in my prediction is really low, or relatively low, I should say, where I have a large number of sample points. And as I get to fewer points, those uncertainty values get higher since we have less sample data there. So if you're someone who wants to dig into this a little bit more, I highly recommend doing so. There's a whole lot of functionality in here beyond what we can discuss right now. So I think that wraps us up, Mackenzie. Anything else we want to throw in there before we say goodbye to everybody?
No, I don't think I have anything else to throw in. As you mentioned, that kriging tool is a powerful tool. It's definitely an advanced tool, and it's something that I'm still learning about every time I use it in Global Mapper. So no questions on that live during the webinar, but I anticipate there may be questions later. And if you do have any questions, anyone, we've got emails on screen now. You can reach out to our licensing team, orders@bluemarblegeo.com, or our technical support team for those more technical questions, geohelp@bluemarblegeo.com. We're always happy to chat with you and answer your questions.
Yep, absolutely. Thank you, Mackenzie, for all the help, and thank you, everybody, for joining us today.